In 1935, a physicist proposed an experiment so absurd he expected everyone to immediately see his point. Nearly a century later, physicists are still arguing about what his point actually was, and a 2025 survey found that the community remains fundamentally split on the single most basic question in quantum mechanics: what actually happens when something is measured? Here is the thought experiment everyone knows the shape of, and almost nobody understands the purpose of. A cat is sealed inside a box with a radioactive atom, a Geiger counter, a vial of poison, and a hammer. If the atom decays, the counter triggers the hammer, which breaks the vial, which kills the cat. If it doesn't decay, the cat lives. Quantum mechanics says the atom exists in superposition, simultaneously decayed and not decayed, until it is measured. Which means, by the same logic, the cat inside the box is simultaneously alive and dead until someone opens the box and looks. Most people who have heard of Schrodinger's cat think this is quantum mechanics describing something real. It isn't. And the actual history of why Schrödinger proposed it makes the modern confusion genuinely strange. Erwin Schrödinger did not believe cats could be alive and dead at the same time. He thought the idea was, in his own words, quite ridiculous. He proposed the thought experiment in a 1935 paper specifically to criticize the Copenhagen interpretation of quantum mechanics, the dominant view developed by Niels Bohr and Werner Heisenberg, which held that a quantum system remains in superposition until observed, at which point the wave function collapses into one definite outcome. Schrödinger's point was simple. If the Copenhagen interpretation is literally true, then it should apply just as much to a cat as it does to an atom. And the idea of an actual living creature existing in a smeared, undefined state between life and death is absurd enough that something must be wrong with how physicists were describing the transition from quantum to classical reality. He wasn't demonstrating a paradox of nature, he was demonstrating a gap in the theory. The problem is that 90 years later, physicists still haven't closed that gap, and the disagreement about how to close it has only gotten more interesting. Here is the actual unresolved question at the center of all of this. Quantum mechanics works with extraordinary precision at the scale of atoms and particles. Classical physics works with equal precision at the scale of cats, cars, and planets. Somewhere between those two scales, the rules change. Nobody has identified exactly where or exactly why. The mainstream explanation is called decoherence. As a quantum system interacts with its environment, bumping into air molecules, exchanging heat, being touched by photons, the delicate superposition breaks down extremely fast, and the system settles into one definite classical state. This is why you never see a person, a chair, or a cat in superposition in ordinary life. Environmental interaction destroys the quantum weirdness before it can ever become visible at macroscopic scale. But decoherence explains why we don't observe superpositions. It does not explain whether the superposition was ever real to begin with, or fully resolve what collapse actually is at a fundamental level. And that gap is exactly where the different interpretations of quantum mechanics diverge, sometimes violently. In a 2025 survey of physicists on their preferred interpretation of quantum mechanics, the results revealed something remarkable. There is no consensus. The Copenhagen interpretation remains popular, but not dominant. The many worlds interpretation, which holds that every quantum measurement causes the universe to split into multiple branches, one for each possible outcome, so the cat is alive in one branch and dead in another, with no collapse ever actually occurring, commands serious support. Collapse theories, which propose that quantum superpositions physically break down once a system crosses a certain threshold of mass or complexity, were the preferred interpretation of about 4% of researchers surveyed. Physicist Lev Vaidman, a leading proponent of many worlds, put it bluntly when discussing a 2024 study that reframed the paradox: many worlds explains everything. Physicist David Riley, discussing the same unresolved tension, offered a more sobering assessment. That's where we left off in the early 20th century. We're genuinely confused about this. A century of extraordinary technological success: quantum computing, quantum cryptography, lasers, transistors, the entire architecture of modern electronics, all built on quantum mechanics. And the physicists building it still cannot agree on what is actually happening when a measurement occurs. In February 2024, physicists published a modern reimagining of Schrodinger's original paradox with a twist that made the situation genuinely worse. Instead of a cat, the new thought experiment placed a physicist inside the sealed box, a conscious observer conducting their own quantum measurement. From inside the box, the physicist experiences a definite, single outcome. From outside the box, before anyone opens it, the entire system, physicist included, remains in superposition, exactly like the cat. The question this raises is sharper than anything Schrodinger's original version could produce. If a conscious human being can be treated as part of an undefined superposition from an outside perspective, then whatever privilege we assumed consciousness had, the assumption that a conscious mind is what finally makes a measurement definite, collapses along with the wave function. The paradox no longer just asks whether a cat can be alive and dead. It asks whether you, right now, might be in a superposition relative to some observer you cannot see. Some physicists find this genuinely destabilizing to how we think about observation itself. Others argue it simply demonstrates, again, that quantum mechanics works exactly as it always has, and that the paradox says more about the limits of our intuition than about any gap in the physics. Meanwhile, experimentalists have spent the last several years trying to answer the deeper question directly. Is there an actual size limit where quantum superposition breaks down? Or does it, in principle, apply no matter how large the object gets? In 2023, researchers at ETH Zurich put a 16-microgram sapphire crystal, a genuinely macroscopic object, visible without a microscope, into a state of quantum superposition, vibrating in two directions simultaneously. In 2025, a team in China created a superposition state that survived for 23 minutes, an extraordinary duration for a phenomenon that typically collapses in fractions of a second. And in January 2026, physicists at the University of Vienna shattered the previous record for macroscopicity, a measurement combining mass, distance between states, and duration by a factor of 10, using a beam of atomic clusters cooled to nearly absolute zero and passed through a specially built interferometer. Physicist Yakov Fein described the achievement directly. "We've tested quantum mechanics again. We've proven that it still holds at this mass and size scale." The team's next target is even more provocative. They are now attempting to send small viruses, actual biological particles, through the same interferometer, testing whether living matter itself can be placed into quantum superposition. Nobody knows what will happen when they succeed, or what it will mean if quantum mechanics keeps holding all the way up to something that can, in some definition, be considered alive. So what does Schrödinger's cat actually prove, 90 years later? It doesn't prove that cats can be alive and dead. Schrödinger never believed that, and Decoherence explains clearly enough why you will never see a superposed house cat. What it proves is that physics still has not agreed on what a measurement fundamentally is, what collapse fundamentally means, or where, if anywhere, the quantum world ends and the classical world begins. Every experiment that pushes the boundary further, every microgram added to the record, every minute added to the coherence time, is physics trying to find that boundary directly, because 90 years of theory alone couldn't settle it. Schrödinger built his cat to expose an absurdity in 1935. The absurdity was never resolved. It was just pushed further out, into bigger crystals, longer coherence times, and thought experiments that now put human observers inside the box instead of cats. The question he asked with a joke about poison and a hammer is still the most serious unanswered question in physics. At what point does a superposition become real, and who, or what, is doing the measuring?